I want to thank everyone for listening, and hopefully there are some questions. Unless Steve or anyone can think of things that I should show that I've forgotten, I'll turn it back to you, Steve.
Yeah, okay, Rick, that was great. Thanks for doing that. So, yeah, I think you've done a great job of showing kind of the complexity and the amount of work that we've put into what we've designed in terms of the geological framework. So one of the things you didn't mention, Rick, is getting access to the PDF borehole logs on the cross-section map. You can get them
right,
but not on the section, just for interest. So there's only a couple of questions, Rick, that have come up. One was with respect to the Dawn formation. Is that part of our model? And maybe you could talk about that for a few seconds.
We haven't. Okay, so for instance, on top of bedrock, we have in some locations we have remnants of York Till. Particularly, we see York Till down along the Lake Ontario shoreline, but we haven't mapped the York Till everywhere, or we haven't mapped the Dawn formation everywhere. In our current rendering, with the data that we have at depth, it's probably going to be incorporated into the Scarborough formation. So I guess that's just our feeling that we don't have enough information to specifically pull out the Dawn formation or that last interglacial. So it would be included in our Scarborough formation. Another thing to think about is that we may map Sunnybrook Drift, which are basically heavy silts with a variable stone component. But the reality of it is those could easily be silts from the Thorncliffe or Scarborough formation. In a way, it's almost a placeholder, the Sunnybrook Drift, for us to bring in an aquitard if we need it. Meaning, yeah, okay. We have to explain variability. We have to explain variability in deep groundwater levels.
Okay, there's a few other questions coming in, Rick. But maybe you want to still show your screen, Rick, with your last
okay. Sorry,
slide.
I gave up sharing.
Yeah, you did give that up, so it just it's less distracting. So there's a question about what's the smallest length that you can draw a cross section on a cross section tool. I don't know. I mean, you can take a crack at it.
The smallest would be the virtual borehole, because that's a point.
Yeah, I think if you zoom in on the map, I don't think there is any real restriction on.
Okay, let me pick. You can also go to an area. So let me try. So I'm in Richmond Hill, Observatory Lane. I'm picking this because my father lives there. Let me move over. I'll go over to Yonge Street. Let's try. So that was a small area. In this case, I'm 90 meters.
Yeah, so I don't think there's really any restriction as far as
there's 24. There's 25 meters.
Right. Okay.
The one I drew before was 50 kilometers.
Right. Okay. So there's a couple of other questions here, Rick. One.
You can see my screen, okay, right?
Yeah. Everything is good. Looking good. Yep. Question: can we add roads or other landmarks to the cross sections, and can you adjust the vertical scale on cross sections? Maybe you could touch on those two.
No, I don't think.
Yeah, I mean, I guess
not
ideally,
yet. No,
not yet.
Yeah. Unless I'm wrong, Annie, we can't do that yet. But like I said, I don't have any wells on here, but in an ideal world, if we had boreholes, you could get at borehole related information. I can also, I mean, if they're, but right now the answer is no. But that is something we should think about.
Yeah, I mean, we were actually pretty happy we got
If
this
I,
cross-section tool to work in
okay, I
general.
just zoomed in, all right, and I can reset the zoom. There's the whole thing, but I can pick an area and go like this, and that should be 10 meters. So I'm showing from 29 to 40 meters, and then reset the zoom. But that's the extent of it right now. It's not like in other software packages where you can change the vertical exaggeration, etc., or add a lot of materials on it. Right now, it's mainly just go away, get our surfaces, get the water table, and plot that. But I mean, we're always thinking about doing things like that, being able to add other things onto this over time. Like I said, the whole site is constantly evolving as we dump our brains into this um, to make it available for everyone to hopefully benefit from.
Okay, thanks for that. There's a question here, is there any rough screening for incorporation of borehole well logs? Say if there are clear errors in one log compared to others.
Yes. Well, okay. So we are incorporating data sets from many locations. And if you think about it, the research, obviously we emanate out from high quality locations, OGS, GSC, landfill investigations, but we also bring in Ministry of Environment, Conservation and Plans, water well records. And like any data set, there are errors in that, and there are errors related to a lot of different things. There are errors related to data input. What may have been put in as in meters was really meant to be feet. And when you incorporate something that's got the wrong units into your geologic interpretation, they'll often show up as bullseyes or huge mountains. So there's a lot of that. Plus, maybe you have 20 wells in an area, and the driller logs the sediments a certain way, and then another driller may come in and drill a borehole, and they log sediments differently. So you have to bring that into consideration. And I mean, some people have tried to put coding on this, where they may code a reliability code, say, related to the experience of the person doing the information recording. So, for instance, maybe some drillers have geologic training, maybe some don't. You can maybe bring that in as well. I think for us, it's more of a visualization of patterns, as opposed to going hard on information is usually unreliable versus this other data set, that kind of thing. I don't know if I answered the question or not, but there's a lot of different ways you can put a reliability indicator on information, and it can be numeric or it can be just you looking at things. And if we see something, so for instance, we've seen a lot of boreholes that state they've hit bedrock at 10 meters deep beneath the Oak Ridges moraine. We think that that's got to be a boulder, given everything else that we know around that location. So we can mark that borehole as it's not bedrock, and we can change it and mark it as such that we have changed it to a boulder. It must be a boulder, or don't incorporate this raw material, this raw information into your interpretation. So there are a number of different ways of dealing with it.
Okay, good. The other thing I would just quickly mention is that they are screened on the position of the wells on the XY coordinates, and we don't generally use wells with a poor coordinate marker or classification in terms of constructing the geological surfaces. We would omit those wells in terms of considering them for geology. So I think I'm just looking at the time here. It's 3:04. So there's a couple of questions that I could still provide to you, Rick, but maybe at this point, given, I think we should respect people's time. So why don't we wind up the official part of the meeting right now, and for all those who have to go and get back to work and do other things, we'll wind up the official portion of the meeting. We'll still stay around and answer questions for those who are interested in staying with us. Rick, maybe leave your screen showed up if you don't mind, because we're still recording the question and answer. Yeah, great. Thanks for that.
Okay.
And so I guess with that, I'd just like to really thank Rick for giving you an overview of what we've done in terms of putting the geological framework together. I think in general, what we found in the past is that it was really difficult to find a solid geological model that you could put your wells into, and we've tried to take the GSC's working conceptual model and push that forward and provide a framework that we could all collectively use and build upon into the future, like Rick said. So we'll give everyone a few seconds to scoot out of the meeting if they want, and we'll have another couple of questions in a second. Well, we'll carry on so people can just leave. So Rick, there's another question here about the distribution of the Oak Ridges Moraine Formation that is shown on the geology layer. So I'm assuming that's the superficial geology layer, and it doesn't match the actual distribution in the region. Can you explain? So I'm guessing that that's maybe tied to the distribution of the Oak Ridges Moraine sediments versus the superficial geology, I think, is that one. So maybe you could carry on with that.
This one?
Yeah, this is what I'm assuming from the question, is, yeah, so that compared to the superficial geology, so maybe some of it's underneath the ground surface,
yes,
is part of the answer.
Yeah, this is the top of, and you will notice, and this is part of that simplification of surfaces that we're posting, where we have, particularly along the south slope, and it came about from a lot of landfill investigations I've done over the years, and in the Pickering area, and 407 exposed it. We're seeing sands between tills along the south slope. So obviously the moraine is thickest over the mound, 300, or the elevation's 344 over the upland areas. But we've also built in, so basically, even though this is the top of it, it'd be better to look at an isopack, and I don't have one readily available here, but that's why we want to get the isopacks up, because what you're going to see over the south slope here, and particularly up in here, is that the ORAC is mixed in with the INS north of the moraine, the inter-Newmarket sediments, because of the layer simplification. And here, what may be, and if Dave Sharp's listening, sorry Dave, the Mackinac interstadial in here, between the lower Newmarket and the Halton. But we really, that's why I think it's best to look at, when we post our isopack maps up, we have them, we just need to post them, right? So yeah, it's a little bit deceiving just looking at a straight top of surface, because it may have zero thickness over a lot of this area away from the actual moraine ridge.
Okay, that's yeah, that's good. Thanks for that. Yeah, I think those are generally. There's another question about cold water streams, showing cold water streams. I don't know if that came in maybe when you were looking at the cross section map. I don't know if that was just in general on the website, or
I don't know if we have that from. I don't know if we have that.
Cold water streams. Yeah, no, I don't think we have a complete mapping of that. It's yeah, we could try to grab some of them from the conservation authorities, but
yeah. So another,
it's not consistent.
That could also be us having available low flow stream flow survey results where we see gaining reaches and by how much flux, because those correspond to cold water fisheries as well, where we have large discharge or gaining reaches from the low flow stream flow surveys.
Right.
Where people walk the whole stream and map the flow at various locations, remote from storm events or rain events or snow melt events, and you can get an idea of where streams are gaining groundwater discharge.
Yeah, and those measurements are all on the location themed map under spot flows. So if you wanted to play around with those, you could see them. Yeah, if you go down and show the spot flow locations. Down a bit. Up a bit.
Down a bit, up a bit.
Yeah, right there, bite your mouse.
Spot flow.
Yeah, so
and then we could have an interpretation of this from the CA, the Conservation Authority, as to which reaches are gaining or losing, because to me that's aquifer mapping, right?
Right. Okay, there's a couple other questions floating in here, Rick. Is it possible to clip the geology layers to a specific area and export them to a shapefile?
I think you touched on that last week, didn't you? That we're working on clip and ship, where you can pick an area, buy a polygon, a square, a polygon, whatever, and it can go and cut data sets, maps, etc., and ship that to you. But we're not there yet.
Yeah, right. Another question here. Paleo, the Lake Peel sediments, are they merged with another stratigraphic unit?
Yeah, right now they're in the upper till units, so we haven't broken those out, Steve. We were looking at that this morning, where we need the late stage glacial lacustrine on there.
And then maybe a final question here. Are there parts of the regional model where you think it's particularly reliable, and vice versa, or the areas where you think that less reliable? Just I guess in a general sense.
Yeah, in a general sense, let me turn this off. In a general sense, more reliable in the western half, less reliable in the eastern half, more reliable, and then over on the western half, more reliable in the sediments, say from the lower Newmarket Till up, versus the deep system, which is infilling this deep Laurentian trough, because we just simply have less boreholes that go to depth across 250 to 300 meters of sediment infill along that valley. So really extreme thicknesses of quaternary sediment are more unreliable than the shallow subsurface, just because most boreholes don't go down to that depth. For most wells, or few boreholes go down to that depth.
Okay, it looks like that's pretty much, we've exhausted the questions. So why don't we wind it up there? So again, thanks everyone for taking the time to join us this afternoon. We'll carry on with our series of sessions. Mason Marchilda next week is going to talk about water budgeting and just a lot of the climate data, surface water data, and how you could maybe make use of that in some of your thinking in terms of water management. And we hope that you join us for that one. Okay, so I think with that, we'll close it off. Again, you can stop the recording, Britt, and we'll hopefully see some of you next Wednesday. And thanks so much.
Thanks, everyone.